Have you gone live yet?
No, I am doing it now. I am now. We are live.
Okay. I'm still actually getting on YouTube.
Yep.
So, hi, everyone. Um, I guess we should start off by saying that I think we're going to do something a little bit different today. The last couple of streams, we've just kind of been figuring out how to stream, getting things going. But after talking to some people, it's kind of become clear to us what we were doing was rigging a pirate, and we were doing a pretty full rig of the pirate. We were kind of taking our time and digressing a little bit, or maybe more than a little bit. But it's become clear talking to people that what we really want to do is basically just rig a character from scratch, not doing much else except using contour. Because there's some techniques in contour that are important to get at and that are not immediately obvious, and it gets a little bit confused when you're trying to do a whole bunch of Maya rigging around it. And it's also worth basically demonstrating that although there is a lot of stuff that you might want to do in a rig, uh, some of the stuff that Raf was doing with the tweak controls, etc., that uses a lot of Maya rigging, you can actually get a pretty good functional rig out of Contour without really using much other than Contour. So I think what we're going to do today is we're gonna take a break from rigging the pirate, and we'll probably come back to the pirate in future streams, and we're going to try to basically rig probably an entire character on this stream. You think that's probably pretty possible, huh? Right,
I think
Raf?
it is pretty possible. I mean, we'll see. Obviously,
We'll
and
see.
we're happy to take questions related to what we're doing while we're doing it. If it's a question that's sort of unrelated to rigging this particular character, like we'll be happy to answer it, but we'll probably like put it off till the end of the stream. But if we end up talking
Yep.
about some stuff, like it may take more or less time, right? But to get the basic thing, yeah, I think that's achievable within a single stream.
Yeah,
So
so we're going to try to avoid getting caught up in a whole bunch of digressions, which is something that's hard for Raf and me. And you get the two of us together, and it's very
yes,
easy for us to get blown off course. But we're going to try to really stay focused here and just demonstrate, okay, this is how you do this. These are some techniques. I think overshoot is a really important technique to talk about.
yes,
And also the idea that unlike in Maya, I think one of the things we really do want to say is when you have things like 90-degree turns, for instance, this is just another example of something that's not necessarily immediately obvious. But if you have a 90-degree turn, like a leg going down into a foot, anything like that, typically more than one chain should be used there. And I think that'll become clear as we go. So I think, Raf, if you just want to get started,
sure.
I think that's probably enough preamble.
Yep, I think it is. I will just note, like, look at this thing. It's I put this together because I wanted a simple character to do some, to give people both as a contour and an ephemeral test. And so he's a weird like alien rabbit dude. I don't really know who he is. I just was amused by the idea that his head was so boxy. So he'll work fine for our purposes. Except for one thing, which I'm actually going to make a little change to him real quick, which is when I was doing this, the ephemeral systems IK does not assume any bend in the leg. Contours does. So I'm just going to shift his knee forward slightly so it's not bent backwards like this. And that should do the trick for being able to rig this character with the ephemeral system. So not that you can't rig characters with their legs bent back, of course, in terms of deformation. It's just a question of IK and how IK functions, and the fact that rotate plane IK generally needs like a bend there to begin with. I am going to turn off the grid, but I am going to turn on wireframe just so I can take a look at where the sort of the end of the main trunk part of his mesh is, and where the legs branch off from that. And I'm going to start drawing in a spine. You can leave the setting the radii till after the fact if you like. I generally do it like while I'm drawing the bones because that's when I'm thinking about it. I'm going to switch to the translate tool to reposition it in a hierarchical fashion, and switch back to our bone draw tool to go move joints around in a coherent way. This is all adjustable after the fact, but it's still nice to, you know, try to get things into more or less the right place when you're putting them down. I think that should do it.
So we do have a question from Ryan Craigraff. He's asking, can you also make the chest and hip controls in IK inside Contour?
Yes, although I think when people talk about Spline IK, they're usually not talking about IK in the same sense that we talk about it with arms and legs. And in fact, a Schleifer type, you know, spine is the sort of thing that Contour does exceedingly easily. You don't even really need IK as such to make that happen. It sort of falls out of the fact that Contour is spline based. And you will see that happen in a moment. Something like that. That'll do. Sort of the average. Let's see, I'm going to throw in a neck. Now you may note, and this will become important as we go along, that in most cases I have some kind of little additional section, an overshoot to my rig. And you'll see this appear in the legs too, which I'll get to in a moment. And that is so that there is a area, an extent of the spline for Contour to use to bend. That was not a great explanation, and this will become way more evident once I start doing the legs. So I'm gonna leave that aside till we get to that point.
Yeah, I don't want to get into a big digression about this, but I will just kind of add to this. To get contour deformation, it needs to be able to look at the neighborhood of the spline around which the point is bound. And it needs to be able to look in both directions. So what happens is if you have a point, points bind to the closest point on the spline, right? So what happens is that if the closest point on the spline is the end of the spline, it will wind up acting as if it were bound to a rigid influence at the end of the spline, essentially, pretty much, because there isn't a neighborhood for it to look at to get the deformation.
Actually, you know what would be, I think, the best scenario? I should actually show what doing a leg the wrong way would be like. That should actually make it a lot more clear. So I'm actually going to mirror this chain over, bind this all together, and then do a leg. Or actually, I'll draw the leg first, but I will do a leg that is incorrect, but which is sort of the natural thing to do with a normal rig, and show you why that's not a good idea in Contour and why you want a little bit of overshoot, another joint beyond the end of your chain. So here's what a normal leg would look like, right? I'm not worried about the foot for the moment. You just have, like, that. There we go. You have, like, 3 bones. Well, 2 bones, really, 3 joints. And that's all there is to it. That's your normal concept of a leg. And here's where the bend would happen for, around your hip region. If we bind this, and the spine, and here, let me mirror this over. We will bind all of these chains to the mesh. The weighting's going to be terrible to begin with, but it should still be enough for us to get a sense of what's going on. Yeah, let me sort of fix that. So I'm going to have to go and fix this terrible auto weighting, but there's no bend in the hip region being created by Contour. So if I go to weight paint, I'm responsible for creating that bend with my painting, which is very much the result. You know, this is very similar to linear blend weighting, which is kind of what we want to get away from, right? And also, like, it's way up in there, and there's a bunch of stuff. But anyway, I'm now trying to create that bend with the weights, and it does not look very good. And I could maybe refine it to look a little bit better, but the reality is, if you want this kind of thing to look good with conventional linear blend weighting, you usually need to add extra influences and stuff. And it actually becomes a whole thing that you have to manage. And a big part of the point of Contour is to not have to do things like that. So in order to get the contour chain to produce, did I actually rotate? Yeah, I did actually. Well, I'm throwing that away anyway. I rotated the socket when I meant to rotate the joint. It's not really a big deal. I am going to remove
So we
this
have another
influence.
question from Ryan, by the way, Raf. He says, I'm new to rigging, but when you rig the hips, when do you define what the COG control is after you bind it? And do you create the COG in Contour 2?
So what I think you're talking about when you're talking about a COG control is your sort of your control that moves the whole upper body around. It's usually centered around the hips, and you would move it around. The reason why I qualify that is that occasionally people use the term in different ways, but that's generally speaking what people mean. And correct me if I'm wrong. I think that's what you're referring to. Yeah, so the COG is just something, a simple control that we're going to throw into the rig, after we've gotten some of these bones down. There's nothing about the COG that requires it to actually be a contour joint. And indeed, you generally would not do so. You would just throw in a curve or something to be the COG. Those are all things that the contour chains would be parented to. Yes, it does mean center of gravity. People have used that term to mean a variety of things under different conditions. It's just, but generally speaking, yeah, that is what it means. So here's what I'm going to do for the legs that's actually going to work well. I'm going to go back to my joint tool, and instead of starting by putting a joint right where the center of the hips would be, more or less over here, I'm going to put it up here instead, so that I get an additional joint or additional bone for overshoot purposes. And the point of overshoot, I'm going to do it here at the bottom of the foot as well. The point of overshoot is that there is now there is an additional section of spline up here, so that contour can produce a nice bend right in this region. I'm just sort of looking at this and being like, do I want, what, we can always change this, like the exact position of these things. Contour is very resilient to that sort of thing, so I'm not going to worry about trying to make it exactly perfect right at the moment. Anyway, I'm now going to bind these to the mesh. Oh, right. I'm sorry. I'm not going to bind it. I'm going to add an influences, since there are, of course, already a bunch. Now, if I rotate this, to begin with, nothing's going to happen because there are no weights painted to it. I'll just do that real quick. No, I need the weight paint tool. Also, I should name these. 1 second. Let me do that before I do anything else, or it's going to be a bit confusing. We have a nice little rename utility, which will affix a prefix to your whole chain. And you may want to go and change the names manually to be things like knee or something like that. But this is quite useful just for being able to take a whole joint chain and give it a useful name for purposes while you're working with it. And you may decide to rename things later, and that's fine too.
And if you do that before you mirror things, it will do something sensible.
Yes, it will. I should have done that. All right, here we go.
But for that to work, you have to begin the name either with left or right.
Yep.
Left underscore or right underscore or L underscore or R underscore.
Right.
Any of those will work.
And now this is going to be a lot easier. All right. So here's what we can do here that we could not do before. Let me make this a little bit easier to paint. This whole region in here. Oh, let me switch to object mode so I can actually paint outside the region of my selection. This whole region here is now getting a contour bend. So when you're doing conventional weight painting, what you typically do is you're doing what I did before, which is you're trying to make the weights localized to this region, and you're trying to paint them very carefully to create the bend that you want, which is quite difficult. With contour, you're not doing that. I am going in here and I'm giving this whole region that's bending Note that I am painting regions up into the spine here to the leg bone, which is certainly not what you would do with conventional weighting, right? And getting actually like a really nice bend. I'll need to like smooth this out a little bit when it gets to the crotch region, because that there you're blending with, you know, sort of in more directions, as it were. But take a look at this. Now, the reason why it's sort of interpenetrating there so badly is because I didn't adjust the radius. So let me do that real quick. I'm going to put it back to bind pose so I can see that clearly. And I'm going to adjust the radius to be, you know, more or less the right amount. And what you should see at that point is that we're getting a much nicer bend. Now, it will eventually pocket a little bit. And in this case, that's happening a little sooner than we'd like. And so I might do something like increase the radius of the joint to change how that bend behaves. I've now got something where an enormous amount of the work of figuring out, oh, what should this look like, has basically been done for me, right? Like, and I can also do things like this, where I can bend it. Well, okay, right now it's being twisted in a weird direction, and there are excellent twist controls in Contour. But note that if I untwist it, it is very nicely doing sort of arranging for a bend that doesn't like pocket in a nasty way and doesn't candy wrapper and doesn't do like a bunch of the nasty things that, you know, conventionally weight painted stuff will do if you don't do anything about it. We'll get to how to handle that twist question, because obviously this twist does not look nice. We'll get to that in a second when we deal with twist.
Okay. So, Raph, Ryan is asking one quick other question regarding the feet.
Mm-hmm.
For the more additive controls like foot roll, toe tap, or even breath controls, would you do that in Contour or something else?
No, so what I would do for that purpose, and we will certainly get to it in this rig, is that I would construct some fairly simple standard rigging to control the foot. So Contour is not really an auto rig system in that it does not set up a reverse foot for you. However, it does make setting up a reverse foot pretty easy to do manually, or to write something around to automate it. Notably, because having handled the deformation very nicely and giving you like good stretchy IK controls, there's a lot less stuff for you to manage. Now, personally, I'm not in favor of some of the things people sometimes put in foot rigs, like foot roll. But there's certainly nothing that would prevent you from doing that on top of Contour. But Contour will not install that stuff for you. Anyway, I'm putting this back to its default position. And I'm going to make sure that whatever radius I gave this thing, which is 3.8, also is on the other side. And I'm just going to check and make sure that the deformation in various areas is looking good, which the answer is no, because I still need to do some weight painting. Contour saves you from an enormous amount of weight painting. Like, think about how easy it was, relatively speaking, like relative to what you normally see for me to weight paint this bend. On the other hand, it doesn't make weight painting go away entirely, because while the area inside the spline, the area that's weighted entirely to this influence, the arm influence, which is one single influence, gives you really, really nice bends by default, the area in between splines, the way that the system blends the deformation produced by multiple chains, still does require weight painting. It's just a lot less than you'd normally require.
Yeah, something we'd like to take a look at some point is doing better sort of default weighting. But because it is pretty easy to paint weights with Contour, it hasn't been a super high priority for us.
Right. I mean, there's definitely algorithms out there, some of which are even used by Maya for doing, better auto weighting. But our biggest concern has been to remove weighting wherever we can, right? Because even with a better auto weighting, your weights are still a pain. And so, that's been our first priority. But it would be nice to get in some additional, like, slightly better auto weighting into Contour, and that's very doable. Just hasn't been the biggest priority for us. I pointed this out with the Pirate too, but since plenty of people are going to watch this who haven't watched that, I will just notice, look what I am doing here that is such a pain with conventional weight painting. I am smoothing, I'm using the smooth brush, and I'm going right into fully weighted sections of the mesh. So this section here is 100% weighted to the spine, and normally speaking, if I tried to smooth that with stuff, I'd end up with values that were no longer 1, on the spine for some of these vertices, and therefore Maya would try to normalize that, and you probably get weird results that you don't like. Contour handles that much more gracefully by simply refusing to normalize them whenever it doesn't make sense to do so, which means that I can freely go around here with a smooth brush and I'm not worried about breaking anything. It does warn me that I tried to do that and it is refusing to do something, but that is, that is in my view like significantly better behavior. It just means that you can sort of go around with a smooth brush and not worry about breaking stuff. I'm probably going to pull a little bit of the spine up into here too, actually. All right, I think this will probably work out okay. Let's take a look. Yeah, I think that's good enough for now. I mean, you could certainly improve this somewhat, but it works reasonably for our purposes at the moment, and we can come back to it if we want to improve it a bit. Now, let's talk about twist. This is an excellent time to talk about it, and we'll go back and talk about it in reference to the legs as well. So, contour, each of these chains, which is actually a spline, treats twist. Or here, let me turn on. Here, this will make it much more evident. It extracts twist from these various joints and propagates it up and down the spline in a very useful way. So, in a conventional rig, you typically have to stick a whole bunch of influences in here and write, probably, or I wouldn't necessarily say write, it's not necessarily an auto rig system, but create some method of managing that twist over a bunch of influences, and it's a huge pain. Contour does this inherently, right? Part of the feature of its spline-based deformation is to calculate twist up and down the spline. And you can even do that with a little attribute that lets you overdrive the twist as much as you want. Which obviously this mesh isn't really high-res enough to do this, but this is actually a mathematically perfect twist that will never candy wrapper if you have the geometry to handle it. But most of the time, what you're doing is you're using the twist that comes off of the joints themselves. But if you twist the shoulder, that twist is going to be happening up here where you absolutely don't want it to happen. Twist on shoulders is one of those classic rigging things that's usually super ugly and difficult to handle. Inherent twist is actually, honestly, one of Contour's nicest features. So what this does is it allows any joint to look up the chain at the joint before it and hold the twist from that joint. So it doesn't matter now how much I rotate this joint. The twist will also always be propagated up to the next joint in the chain and not happen right around the shoulder where you definitely don't want it. And this applies equally well to the hips. So if I rotate the hips out here, this is an awful twist. If I turn on inherent twist, suddenly it's quite nice and pretty much exactly what you want.
By the way, Ryan is asking, that weight painting you're doing is Contour's own painting tool. And yeah, it is. I mean, our weights are entirely our own thing, so
Yep.
we have to have our own tool. And Brian, my colleague Brian, wrote the interface to that, which was it was a fair bit of work.
I recall it being actually pretty difficult to do. And, but it does mimic the Maya, the Maya weight painting tool very nicely. Which I very much appreciate. Because it's something that we're all just used to, and, we don't necessarily like using it, but we know where everything is. So, anyway, what's next? 1 second. Let me just turn off a notification. I just don't want that, popping up where I don't want it to be. Is Slack actually active here? Yeah, that is it, and let's quit that. There we go. I did not want it popping up any messages in here, Slack does that.
Related to NDAs.
Related to, any NDA-related thing. I have clients who use Slack, I probably should have turned that off beforehand, but now that I saw something pop up, I'm turning it off now. Let's see. Right, let's make sure that we set all of these things to also use inherent twist. And not forget that. Not that it would be a big deal. If we did forget it, we would just fix it, but...
Okay, so we've talked about overshoot in the hips wrap, but I don't believe we constrained those to the spine yet. And so maybe that would be the next thing.
Indeed, we have not. And I think that is the next thing to do. Let me disable the radius indicator for the joints. Because we don't really need it right now, and it is visually, it's just a whole bunch of stuff and a bunch of rings and stuff sort of stuck on top of your rig, and it's better to hide it when you don't need to see it anymore. So yeah, let's talk about that, because one of the
Yeah.
issues that we have is that these sort of starts to the chain, this overshoot to the chain that gives you a little bit of section of the chain that happens before the actual bend of your leg, needs to follow along with the spine in some reasonable fashion. Before I do that, let me just mirror the weights, actually, because if I don't do that, we're just going to get super wacky weights on the other side, and it's going to be distracting. And this
And I'll
pretty...
mention that this technique of constraining and
Mm-hmm.
overshoot is a really important one. This is what makes overshoot sort of work reasonably,
Yes,
right?
it absolutely is. Like it's
So
actually a really central aspect of what you can do with contour, and the kinds of things that you can do with it turn out to be exceedingly useful. So in order to demonstrate what the difference is going to be, let me add a bone CV to the spine. So we were just talking about IK spine, right? So typically speaking, when people talk about an IK spine, they don't mean IK in the sense of like rotate plane IK like you'd have with an arm or a leg. They mean usually some kind of spline IK. Which is, should that actually be called IK? I don't know. That's a rant for another time. The point is, it's very, very easy to do that in contour, because every contour chain is a spline. Like that is what contour chains are for. They're for describing the spline that's going to actually deform the mesh. So I can, to any bone, add a bone CV. And the bone CV automatically lets me deform the mesh along that spline. I mean, all it is doing is adding an additional control point. And all joints really are in contour are control points on the spline, and the spline is what actually deforms the mesh. So there is, however, something a little weird going on here. So in this section, this is working quite well. Like, it goes up into the arm, and like this is pretty much what you'd expect. But this here looks kind of weird, doesn't it? And the reason why it looks weird is that we've weighted a significant portion. Like, let's go back and take a look at our weights again. We've weighted a significant portion of this to the leg. And this area to the spline. And so you can see that we're losing some of our advantages of that contour deformation in this area. To solve that, it's what we want to use is a deformed field constraint. And the deformed field constraint is actually an exceedingly powerful feature of contours, which is useful for a fairly wide variety of things. But this is one of the main things that it gets used for, which is essentially what it allows you to do is to drive any transform as if it were a deforming mesh, even though it's actually just a transform. And that works because contour does, while it is deforming a mesh, its calculations to figure out what it should do, like how it should spread the mesh around to get a nice look, how it should twist the mesh, are not actually dependent on the mesh itself. It has this concept of a deform field. And the deform field can be used to drive a mesh. It can also be used to drive other things. So, here is something I'm going to do. I'm going to constrain these contour joints. Actually, I am simply going to unparent them, I think, because that is a thing, and it's worth noting that you can do with contour. It is not necessary. Let me get my outliner back. It is not necessary in order for these joints to drive the spline and therefore the mesh correctly, for them to actually be in this hierarchy that they get created in. This hierarchy is quite nice, and it's useful for a lot of things. So the way the contour works is you've got joints, and that's a concept most people are familiar with. I mean, that's how it works in Maya. They're transforms. But you also have bones. Bones are not a concept you usually see in Maya. And bones have a length. If I change the length of the bone, it will actually change, well, it will change the length of the bone. And they buffer the joint, which is why the joint is zeroed in both rotation and translation in its default position. In Maya, with joint orient, only rotation is buffered, which is often not very nice. Sometimes, because a lot of the time you really need to buffer translation. Especially if you are going to animate the joints directly. Something people don't usually do with Maya joints, but which we wanted to make sure was a completely viable option with contour joints. So we can take these joints and we can unparent them. I'm doing Shift P here and unparenting them. And that now means I can drag this around and the joint next in the chain will not move around with it. It's no longer parented. It's a perfectly okay thing to do with contour. Although it should be noted that some of our tools for manipulating joint chains, like mirroring them, will no longer do a useful thing in that case. You do have to keep that in mind. But there's nothing about how Contour behaves that necessarily assumes that you have to keep the chain parented the way it is. So what this now means is I can use my, let me just turn off selection of a mesh. I can use my contour deform field constraint to make these things move around as if the spine was deforming them. Look at that. And now they are actually, you can see this bend happening very, very naturally. If I wanted to be able to move this around and sort of get something that behaves pretty much like a Schleifer or ribbon spine, or like the various types of sort of Spline IK adjacent way that people do splines. 1 minute. Need to turn that off. That would be quite easy to do. All I would need to do would be to add an aim handle, which you can't really see because it's a locator and it's buried in there somewhere. So let's go get our aim handle we just created. Here it is. And tell its locator scale to be larger so we can actually see it, right? So now, well, this is not going to look like much if we do not actually parent this stuff to the upper part of the spine. There we go. That's more like it. And it is not orienting anything right now, so we will also use a contour orient. An orient constraint would also be fine. Contour orients do something a little nicer in terms of the way that they use the override rotation features of contour, which we'll probably discuss a little bit more when we get to doing contour IK. Whoops, wrong handle. There we go. So, in answer to the question, how do you do spline types of IK? Well, this is it. Like, we've just done it. And we can even grab this and have a whole bunch of control over the way the spline bends, and like bend it in any direction we want. And we can twist it, and contour will very naturally just do the right thing. And that's a really essential thing. One of the things, and I want to be very careful not to get into too much of a digression, because we've had the issue with our streams here of digressing quite a bit, and I want to keep this a little bit more focused. But I do think it's important to note in this case that the thing that contour really gets you is the ability to have a primitive for rigging with these splines that gives you the right results for the majority of the things that you want automatically. So, not necessarily everything. As we were just discussing, you do have to do a bit of rigging on top if you want a reverse foot rig. But if you want the ability to twist a mesh along a spline and have that twist be stable and easily controllable, well, you can do that, and it will cost you absolutely no additional effort. In addition to which, it will just look really nice.
And this guy looks pretty nice, given that we haven't
That's
really
right.
done much in the way of rigging other than give him some chains.
Exactly. We have done very, very little, and yet we're getting a good result. And that's one of the central things we wanted. The idea that, good results from rigging should be more automatic, right? There are certainly some things that will still cost effort. We've been discussing some of those things on our other streams. But a great deal of the effort that goes into rigging are problems that you end up having to solve again and again and again. And if there's a central idea, this spline-based deformation, that essentially is a good fit for those problems, a lot of those problems basically go away. So, we were just talking about a cog controller, an upper body controller, whatever you would like to call it, and now is actually a great time to add it. So I will take this top spine control, you can call that, shoulders or chest or whatever kind of control you'd like it to be, and I will stick a circle shape on it, which just adds a NURB circle. It's just a convenience because this is something you would like to do probably in a lot of cases for many things that you do with contour. And I'm going to make it a little bigger. That just gives us a nice way to select it, and I can get rid of the locator part of it. In case you're curious how I did that, I just selected the locator that's a transform. I hit the down arrow to get the first thing parented to it, which happens to be the locator shape in the case of locators. And I'm now going to hit Control-H to hide it because we have a different way of selecting the locator. So in order to do something similar for the hips, there's no need to make an explicit handle. I can simply add a circle shape that I'm going to use to control my hips. I'm going to put it more or less like where this joint is. It's not even essential that it's necessarily exact, although, it would often be nice that it is. But one thing I am going to do is I am going to change it to be pointing down X. And this is a point that's maybe worth noting. So if we look at, and I'm pretty sure that we are looking at it, at these handles in object space, and we are, if we look at the direction that this circle control is pointing, X is pointing up. And contour, by default, and this is certainly something you can change, you're not locked into it, but by default it makes the assumption that your bones are pointing down the x-axis. And the reason why it makes that assumption is that makes XYZ an appropriate rotate order. Well, or XZY, I suppose, in some circumstances. But anyway, the point is, it's a convenient assumption to make. It's often true. It's not always true, and you are in no way obligated to do so. Contour chains do, in fact, allow you to change the bone axis. But since that is what we're doing here, we want all the controls to sort of follow the same assumptions. And this control, which was generated off one of these joints, already does. So we're going to do the same thing for our control that we're using for the hips, which I can now no longer select because it's stuck inside his body. I have now changed its normal to be X for this nerve circle. I'm going to make its radius big. And of course, the obvious issue with it is it's not pointing in the right direction. Now it is pointing in the right direction, but it's not buffered. Just make it a little bigger. There we go. Buffering a control, you know, it's a concept that's maybe familiar to a lot of people, but not necessarily to everyone, is essentially what you do to zero it out. Now, in more recent versions of Maya, there's another option for doing this called offset parent matrix. But because you may or may not be using more recent versions, we're not going to use that right now. We are just going to create a buffered control. This is something I would normally do with ad-hoc Python, but I promise not to do that for this stream, because a lot of people don't necessarily want to deal with learning any Python, which is completely reasonable. So all I have done here, I want to make a locator. Actually, I'm actually doing this a really silly way. Let me do it in a slightly less silly way. I have just made a group, right? I'm going to set that group to have the same transformation as this nerve circle I just made, and I'm just going to use match all transforms to. I selected them in the wrong order. There we go. So now this has just been given the same transformation as this nerve circle. If I now parent the nerve circle to it, the nerve circle is fully zeroed out, which is what we want in our bind default pose that our character has for rigging purposes. I'm going to name this pelvis control, but apparently I can't type. And I'm going to name this chest control. And I'm going to take this, I'm going to take both the joint socket of my spine. Now, we did not actually mention joint sockets, and I think I should probably really briefly mention what they are. So by default, these joint chains are a joint, a bone, a joint. Well, that's a bone CV. A joint, a bone, you know, a joint, a bone, right? But something needs to start them off, and something needs to buffer that first joint. And it was convenient for us to have that thing be the thing that you use not only to, in normal circumstances, parent your chain to. You're not obligated to do that, but it's useful. But also to be the thing you use in the scene to refer to your particular spline. So if you want to, for instance, when you saw me create the deform field constraints, I was selecting this as a way to select that particular spline and then shift-clicking other things in order to apply the deform field constraint. So in this case, because we want the bottom of the spine to follow along with this control, I'm just going to parent the spine to it. And then I'm going to take these, which are these freestanding joints that aren't parented to anything right now, and I'm similarly going to parent them to the spine. Or rather, I'm going to parent them to the pelvis. So now, here's sort of the other side of our sort of IK pelvis type thing that you can now move around in any way you want. And it was done pretty simply by just parenting some stuff. For anyone who is not already familiar, and many people in this audience may be, but for anyone who is not, that's normally really painful. Like, if you were to like do a ribbon spine or a Spline IK type spine from scratch, we'd be here. This, you know, that'd be a stream all by itself, right? We just did that in like 5 minutes, really, when you get right down to it. And a lot of that was just mentioning what it was I was doing. So I'm going to add a circle shape to this this bone CV as well, and that now means that we can move the torso, well, the shoulders, like whatever you want to call it, and the pelvis around independently, and have this middle control that we can then move around, which, is actually a somewhat advanced, spline IK type thing to do. That is not even true of many IK spines. I'm going to reset all of these to 0. And also, it is worth noting that we are making our actual bone CV an animatable control here. And in terms of the rigging that we're doing for this character today, that's generally the philosophy I'll be following. For Maya rigging, it is common to have an entirely separate hierarchy for your control structure as for your actual joints. And there's a variety of reasons for that, but a lot of it has to do with the fact that Maya joints do not actually make very good controls. In the case, however, we wanted to make things much simpler, especially for people who are trying to put together something in a relatively simple way, who want to basically be able to throw some joints into their character and have them do a reasonable thing and not think a lot about the organization or architecture of their rig. Now, it is often a very good thing to be thinking about the organization and architecture of your rig, but it tends to be a stumbling block for people who are not particularly familiar with how rigs behave or the various ideas behind how to construct control rig structures. And even if you are pretty familiar with that, this still greatly simplifies what you need to do. It is perfectly okay in Contour to simply use your joints as controls. They are zeroed out and by default, and you don't actually need to do anything to them in particular to make them viable controls for your animators, other than, adding something to let them select them easily, which is what we did by adding a circle control. You can add any other kind of, NURBS curve to that if you want to. So yeah, we've got a spine here, but let's add a cog or an upper body control. I tend to call them upper body controls, but we're going to throw down a NURBS circle. In this case, I'm going to give it 4 sections and linear, so it's like kind of a diamond shape, because that helps differentiate what it's for from your standard circle shapes that are not your cog. And people have different ideas about what this should look like, and really you can do whatever you want. Type that wrong. Point it down X, rotate it 90 degrees, put it in the same position. Well, actually, make it bigger first. Give it the same transformation as our pelvis control. And we'll now parent, let's call this upper body. We're now going to parent this to that null that buffers things, and parent the pelvis control to it, and then we're going to go ahead and parent literally everything else to it. And including these legs, which we actually don't need to parent them to anything, but this actually helps with dealing with scalable rigging, if you do, which we can get to in a second. Scalable rigs are super easy to do with Contour. This rig will be scalable by default, actually. Here, let me show you. Look at that. You know how much of a pain scalable rigging normally is? It pretty much just works with Contour unless you're doing something a little unusual. So now we have a pelvis that we can move around, and a chest we can move around, and some control in between, and an upper body that lets us move the whole thing around. That's your cog. Let me just zero this stuff out. All right, let's do arms and legs. So the arms, by default, we kind of already have FK controls. I really want to go back and fix that, but I'm not going to do it right this second. We pretty much already have IK controls. FK controls, right? The joints can serve as FK controls. I mean, they're rotatable, they're zeroed. So let's just add some circle shapes to them and make them our FK controls. All right, a couple of them are buried in there. There we go. I'm going to push these. Well, the direction, of course, is not actually mirrored. Translation is not mirrored. So I'm going to have to make that center difference negative. There we go. And now we have some FK controls, which will work perfectly well. We also want IK controls. Let's add some contour IK. I will select these three joints that I'm going to use for my IK. And I'm going to add a contour IK handle. It will automatically add a pull vector. The contour IK, here, let's just take a look at it in the outliner. Here's our IK handle. Let's make it a little bigger so we can see it. We'll do IK exactly as you would expect. And it looked at in order to figure out the rotate plane, it looked at the bend here, which is why it's sort of already all arranged in a useful way. Contour IK includes a lot of features that are common among more complex rigs, but that you don't generally get to sort of throw into your rig in such an easy way, including things like auto stretch, where it will, auto stretch beyond the point, very, very common, but also smooth stretch. So if I turn smooth stretch to 1, what that means is that it will do this smoothing in to avoid IK pop, which is a classic issue that animators experience. So if I turn off smooth stretch, you see that pop, the IK pop. It's the ugliest thing ever, and I hate it. Right? It's the worst. Smooth stretch gets rid of that. A value of 1 is usually the right thing to do. See how no more IK pop. It's easing it in a little bit by stretching slightly as it approaches the extent of its sort of canonical length. That was a weird way to say that, but hopefully you guys get the idea of what I'm saying there. You can even overdrive it. You can give it a higher value, which is now going to do super extra smooth IK, but is often not what you want. A value of 1 is usually the right thing. But as you can see, as a result, it is slightly bent, slightly more bent in its default pose, because that was already pretty close to straight. And the whole point of smooth stretch is that it increases it starts stretching them a little bit as it approaches straight. So, whether you want to use it, it definitely has the possibility of affecting your bind pose. Whether this is actually an issue for you, probably not, but it is a thing that happens. So let me throw some circle shapes. Actually, let me make ones for the other side first. Which will, act in exactly the same way. Let me throw some circle shapes on this. Did they get made super tiny? Yeah, they did get made super tiny. That's probably the default in Maya. The reason why these were a reasonable radius is that we actually look at the radius of the chain when we make these to try to give it a more useful default. These ones are not such a useful default, because there's no radius of the chain to refer to. But we can just make them big. This is a thing that I just sometimes do for IK controls because it's simple. I make them look like that. There we go. Let's hide the locator shapes. And I'm actually gonna, for the moment, I'm gonna leave these pull vectors as locators, because that's kind of a useful shape for them to have. You can, of course, add whatever kind of NURBS curve, controller selector thingy to that you desire. I think it's fine if they're locators for now. So, how does blending FK and IK work? It works like this. There is an FK-IK switch control automatically added to the IK control, and it will blend it back to FK. You are free to rotate your FK around however you like, and the IK control will just blend to IK in exactly the way that you would expect it to. And that is a base feature of the contour IK handle, and it does it by driving these additional attributes on the joint. These override rotation attributes and override blend, and because stretchiness is an option, it is also driving on the bone its override blend and override stretch value. So the really nice thing about this is this stuff all comes for free. It's built into the IK handle. It's stuff that people often do with Maya rigs, but it always requires a great deal of additional rigging complexity, generally necessitating some kind of auto rigger or something like that in order to reasonably do that for multiple characters in a reasonable amount of time. Here, it's just something the IK handle does. I'm just going to reset all of this stuff to 0. There we go. Let's do, well, actually, before we do the legs, let's actually talk about feet for a second. This is probably a good time to do that. So it is worth noting that you have overshoot on the feet, just as we have on the the hips, for exactly the same reason. If we ended our chain right here, we would not get nice contour deformation in this region. If we instead extended the chain in this direction, we'd run into a different issue, which is that contour has issues binding with angles in the spline that approach 90 degrees. And the reason why it does is, in order to know what part of the spline it should bind any vertex to, it has to look at the closest point on the spline. And if you have an acute bend, it may be ambiguous. There might be a closest point that's actually not where you expect it to be. So to deal with that, what we generally do is have multiple chains. So here's how that would work. I am just going to make a chain that kind of goes like this. And like maybe put it over here or something. I am going to name it foot.
I mean, I think it goes beyond that a little bit too.
Actually, left
I think
foot.
I think
sorry.
even if you could force binding, force it to bind to the part of the spline that you wanted to for the vertices, I still think you'd probably get better results from this, don't you think?
I do think so. I think that any situation in which there's ambiguity, like, yeah, maybe it's possible to imagine some scenario where you could force it to the right part of the spline, but I don't think it would be worth it. Like, I think there'd be a lot of complexity in figuring out how that should work in terms of user point of view. Like what should the GUI be like? How would the user interact with those tools? I think this is just simpler, actually.
Sure. I also think the result may actually be better.
That is certainly possible because it is very simple to basically be like, well, how does this bend going to behave? Right? Starting from a straight-ish, obviously does not actually have to be straight. Like, this is perfectly okay. Point of view gives you a lot of consistency in this behavior. So let's mirror this over. Let's rename it. Parent it so that now when we do this, we get a useful, well, I mean, obviously this doesn't look good yet because we haven't actually painted any weights to this one, and therefore the bend is extending like basically throughout the foot. But, you can see how that would look good, if we, with the thing that we are about to do. Yeah, let's increase that radius a bit, I think. And let's add it to the mesh. All right. So, oops, I meant to do this one. One thing to note here, this occasionally happens when you have already selected verts at some point, is that it will put you into vert mode when you may or may not want that. If that happens, I mean, it's easy enough to switch to object mode, but it's just worth keeping that in the back of your mind that can happen, and it can be a little confusing for a moment. So let's take a look at these feet. Here's our left foot. I also would like to increase, because like this is a little weird looking, right? So I'm going to increase the radius and get like a slightly nicer result. And what was that, 3.1? 3.1. There we go. All right, so what this means is we can now bend the, well, let me get rid of these circles. We can bend the toe. It does toe bendy things that you would expect it to do. I actually might want to adjust that slightly. Yeah, 1 second. It's always nice when you don't have to paint weights, because every time you do, it's a pain. This is why we wanted to make weight painting something you don't have to do as much. That's a little better. All right. And here's your toe, and here's your foot. So the foot, you're getting all of this deformation from the foot, including the twist. Here, let's just, there we go, including the twist and bending and everything that you'd expect. And then you have this additional chain that does the toe. And that's how you handle 90-degree bends. Only one of these needed overshoot, because this region, this bending region, is weighted primarily to the leg spline, which means that there's no particular reason why this one needs overshoot, except in the sense that I suppose you could say that this here is overshoot, right? So actually, to be fair, we kind of do have overshoot here, because again, you get the nice contour bend when there's spline on either side of your control. All right, let's throw some IK handles onto that. I should probably name these in addition to going and giving them some circles. Let's turn off the mesh for a minute. I'm going to add circle shapes to them. I'm going to basically set them up the same way that I was doing previously, where I made them little diamondy things. And then I'm going to do the same for these joints for the ability to manipulate them as for FK foot, toe purposes, as well as to all of the foot controls, or rather the foot joints, which are also now foot controls. But these two are not buffered. This is actually a useful point to make. The knee is, because it's part of the joint chain. The hips are not, because they are not part of a joint chain. So I'm going to buffer them, because you definitely always want them to return to a default bind position when they are zeroed out by an animator. And I've just, this is normally something I would script, but I'm just going to do it sort of the old-fashioned way, because I promise not to do any scripting on this one. Yeah, is that in the right place? Yeah, it is. So put that under here. Put this under there. Oh no, that actually goes under the pelvis control. That's right. Actually, come to think of it. Oh no, those are actually in the right place. Same here. Should put this one in the right place. Spot. It does indeed. There we go. Now they're buffered. So now they can be controls that the user can move. These are not very selectable. Actually, neither are these. Let's make them a little bigger. Okay, so what we now have, let's hide joints for a second. What we now have is a full, well, full-ish, right? Oh, we haven't done the head yet. Well, let's ignore the head for the moment. I'll come back to it in a moment. We actually have a reasonably full idea of a rig here. Now, it does not have every single feature that you would want. For instance, it obviously does not have a reverse foot, and that's probably the next thing that we're going to deal with. But it does have a lot of other features that you would want, except, of course, I neglected to mirror the weights, which is why that toe looks wrong. 1 second. All right, this should look better. It has a lot of the features that you would want. It's got stretchy IK. It's got IK-FK switches. This rig would actually be pretty useful for some purposes. Here, let me just get rid of these locators for a second and tell this to be stretchy. There we go. Not too far away from a rig you'd actually want to use, but not quite there yet. Because reverse feet are actually kind of important. And that's where we do have to break away from the sort of nice world of everything's contour and everything just sort of works and do a little bit of additional Maya rigging. But it's not a particularly large amount. It's certainly not like the, more complex rigging that we were doing, when we were adding like extra tweak controls and a bunch of other stuff to our pirate. So let me actually do the head first and just get that out of the way, because I think that also introduces another concept of rigid influences in contour that's very useful. So right now, I'm not really sure exactly what the head weighting looks like, but probably this is actually fine, because if we change the neck, yeah, that's all working nicely. Neck's fine. The head, however, note this like weird, that does not really look good, right? This is not really what you want the head to look like when it bends back. So we do want this to remain contour, because we get all of this nice stuff where like the twist on the neck happens for free, and we can go and translate the head and have it do a useful thing. Because again, why are we able to do this? There's no complex rigging involved. It's because there's a spline underlying this, and you move a control point of a spline, it does spline things. So stretchy controls are inherent. You're not obligated to use them. You can certainly rig stuff up with contour that, is a more conventional rig that maintains its proportions. But stretchy rigs, instead of being a thing you have to do extra work to enable, is something that is just sort of inherent to the features that contour allows for. And you can just choose, whether you stretch or not, just depends on what you expose to animators in terms of controls. So we are going to add a rigid influence, which is another thing that contour does, which is just going to be some locator or other. I'm going to parent it to the head. I want to make it big so I can actually see it. I'm going to call it head influence, and I'm going to add it as a influence. Blah blah blah. Sorry, my brain's a little fried today. I'm clearly looking at in the wrong menu. Yes, here is the one that I want. Add influences. Yes, let me, before I do anything else, let me also add some circle shapes to the neck and the head. Yeah, let me, not sure why it is not, oh, here it is, because I was looking at the wrong thing. There we go. That's what I wanted to say. Or rather, what I wanted to see. Yeah, that'll work for now. All right. So, I believe we already added it as an influence. We can now paint to this rigid influence as one of the things we can paint to. Head influence. The head influence, of course, is not a spline. It is not a contour chain that generates a spline. It's just a control, which is a transform, just like a Maya joint. In fact, I'm pretty sure you can use Maya joints for it if you want to. But yeah, well, this is of course very silly. Let me just
Actually,
select a bunch of
Ref,
birds.
I think Maya joints are the one transform that you can't. You can
That's
use a different
right.
transform, but there's something a little bit odd about the way Maya joints work
I think it might have
that
had to do
prevents
with
that from
joint
happening.
orient, and like there was something weird about it. Yeah, all right. So you can't use Maya joints, but you can use anything else. And so this is going to act more or less as linear blend skinning would, in the sense that it's being weighted with the results of contour. We haven't added any extra deformers here. This is it's still just the contour deformer, but we do have scenarios where you really want a rigid influence. But since the neck is still mostly contour, you still get all this nice twist completely for free, and the ability to just pull it around if you want to. Let's hide this. All right, so we've now dealt with the head. So now it's a rig that, assuming you didn't mind not having a reverse foot, which you probably would mind, but assuming you didn't, you could actually use, and it would actually have, in many ways, features that are nicer than many rigs that do include things like reverse feet.
Yep.
Because
And
your average,
that's
yeah,
I'll note we've been on for about an hour, and obviously this is a lot slower than it would normally be because Raf's been explaining
right,
a lot of stuff. This would be what 20 minutes of work for you
yeah,
if
pretty
you were
much. This would be very,
yeah.
very easy to do,
So
and that's
for
that's
simple
the nice thing,
stuff,
yeah.
to get a simple rig on a character that does something that's pretty decent. I mean, it's very quick.
Right. And that was certainly one of our goals, was to have this be something where animators who were not, necessarily rigging experts, but wanted to learn a little bit of rigging, could actually do something really nice that would give them a lot of nice features, and that they didn't have to work super hard to get, but without necessarily relying on the brittleness of an auto rigging system. Let's make these a little bigger because it bugs me. All right. So let's talk about reverse feet. So obviously, this is not necessarily the best way to handle this. Well, the way I've been doing reverse feet, there's a bunch of questions, I suppose one would say, about how reverse feet ought to work. Sometimes, and this is what TSM3 used to do, right? You'd have the pivot be back here so you could sort of do your heel strike pose. And sometimes people like the pivot to be over here where the foot's actual pivot is. I've gone back and forth about that, but in the ensuing period of time, I've decided that ultimately I do prefer to have the pivot up here at the ankle. And the reason for that is that having it down here presupposes that you're doing a very specific set of things with your rig. It presupposes you're doing this particular strike pose, and you need to rotate from there, and a variety of other things, and I don't necessarily find that to be necessarily always actually true. So I am going to keep the control basically on this, at this location, but we do need the ability to raise the heel. Like, that's pretty non-negotiable, and we may also want a pivot sort of like up over here right at the toe, where we can pivot the whole foot back from that. So yeah, this is a thing that we can certainly create. And we're going to do it in a, I would say, pretty simple way. I'm actually going to go name this stuff first, because otherwise, I'm going to have to go back and name even more stuff, and I don't feel like doing that. So let's see, what do we have here? This is left hand control, left hand PV, right hand control, right hand PV. It's absolutely the sort of thing I would script if I could. Left foot control. I should say right hand IK control. Actually, that seems important. Important information. All right. If I were like doing this as a rig I was doing for a client, I'd make a point to name all the buffers and stuff too, so things were a little clearer. But for our purposes right here, I'm not too worried about it. So here is what I will do, actually, because what we really want is we want to have all of these controls available to us, all of these attributes that we can adjust. But we don't really actually want to use the actual IK handle itself, because ultimately we want this IK handle to be moved around by something other than itself. This is not the thing we're actually going to select. We're going to have a control up here at the ball of the foot that's going to be able to rotate this thing backwards. So to make that easier to deal with without scripting, I'm literally just going to duplicate these. So I'm going to take my 2 feet controls and I'm going to duplicate them. And control 1, these ones are going to become the actual controls, and these ones are going to end up being adjusted, things that get parented to the ball of the foot control. So, left foot IK control. Let me get rid of its shapes in here because there's more than one of them. I won't just use the down arrow. I will actually take a look at the shapes that are under here. I'm going to get rid of both of them. And instead of being a control, I'll just call this right foot IK because it's not the control. We are not going to actually be doing that. But it is still what controls the IK. It's just not the actual control. This is going to be the actual control once it does something, which it currently does not do. Yeah, let me just not look at shapes anymore. In order to create the ball of the foot control, I'm going to do another circle. I'm going to make it a diamond because it's IK, and that's sort of the shape language I've come up with for this rig, even though, whether this is really what you do in every circumstance, I mean, probably not, but it's what I'm doing right now. And I'm going to basically make it be in the same position as the toe control. Only it's tiny. Let's fix that. There we go. And I'm going to make one for the other side too by duplicating this and matching these transforms. And I'm going to buffer both of them, and I'm going to name them first. Also, apparently I can't type. Yeah. You would think that I would make more typos when typing normal text, given how badly I type when I'm coding or typing names or stuff. But actually, I'm reasonably okay at typing paragraphs of text. But for some reason, when I'm switching contexts, I tend to screw up my finger placement. I lose my ability to touch type for a moment. All right, let's, because we want to have an additional control that we're going to be able to pivot back from at the toe, let's duplicate these again. Pull them out here. Let's take a look at our joints again, because we want to be able to put those exactly where that toe joint is. And let's make them smaller. And because I duplicated them, they've now lost their circle generating thing that lets you control radius. So we're just going to select the verts and actually scale them down. And probably pull them out a little bit too, because that's going to be a little hard to select if they're interpenetrating the mesh. All right, here we go. So, these should actually, to disambiguate, let's just be clear about this. And I'm going to buffer all of them. Oh, right. I need to rename that one. I did not mean to do that. Absolutely something I would script. Make sure they're in the right place. Looks like they are. All right, now that these are buffered, I'm going to put them in a reasonable hierarchy. So this one, for instance, I just selected it and then hit the up arrow to select its parent in the hierarchy, i.e. its buffer. parent that to the toe, select the toe, parent that to the foot control, which actually should no longer be named 1. Same for the other side. And finally, I take my left foot IK and I parent it to the ball control. What that means is that you can rotate the whole thing from the control. Now, of course, it is doing something really weird here. The toes are not actually hooked up to anything yet, but we can fix that. And what we are going to do to fix it is actually create some of those additional aim handles that we have used in the past. So I'm going to create an aim handle for this one, and I'm going to parent that aim handle, directly to this toe control, which means that we now get the result that you probably expect. We now have a pretty simple, here, let me just hide the joints there for a second. Pretty simple, but very functional reverse foot rig. We can do that. We can do this. The only thing we can't do yet is do things like adjust the settings to, say, change the FK-IK switching, because that's, this is actually just a duplicate of the actual IK control and isn't actually hooked up to anything. So we can go hook it up. Put these all back where they belong. No, I think I forgot to, yeah, there we go. And this one too. That's more like it. Let's see, yeah. So as you, if we look at our hierarchy here, at the very end of it, here's our left foot IK. I'm going to do this manually in the node editor. Bring in my IK control. Bring in my left foot IK, that's the actual IK handle. And I'm going to basically do this. This is not actually the most efficient means of doing this, but it will work perfectly fine for our purposes right now, and I didn't want to overcomplicate things. All right, this now means, and it's going to reveal an additional issue, but I can now, now I was expecting this, because there's an additional thing we need to connect. But it is clearly acting as an FK-IK switch, and all of the rest of this stuff should work too. Well, not that that's doing anything right now. Oh, probably because auto stretch is on. Oh, actually because FK-IK switching isn't on. That's why it wasn't doing anything. Turning on auto stretch. It now auto stretches. All right, so everything is all hooked up as you would expect it to be, except of course for the fact that our aim here is not responding to the FK-IK switch, which is why it's all screwed up. So real quick, I am first of all going to hide those. Well, these are the aim constraints, so let me grab them first, or rather the aim handles. We need our FK-IK switch to also get plugged in to the aim handles switch in order to have any useful result. So left foot, left aim handle. This has a blend. FK-IK switch gets plugged into blend. This should work. Let's just see real quick if it does. At this point, yep, it just goes right between them. Because this is intended in part for people who may not be as familiar with these rigging concepts, I wanted to take a moment and ask, our viewers, Like, am I going too fast here? Is what I'm doing here making sense? And it'll probably take a minute because there's a significant amount of delay on the stream. But if anyone wants to throw out comments, like, I'll be happy to clarify anything here that doesn't make sense. And we're going to do the same thing for the right side. And let's see if that works. Yep, that also works. All right. Let me hide those now. No reason to look at them anymore. And now we actually do have, I mean, look, we have a rig here with FKIK switching, well, blending, with a, you know, pretty acceptable reverse foot rig. And now, I mean, like, literally, like, you know, there's probably some stuff I would want to do to this rig to sort of clean things up a little bit. I mean, among other things, I should really add, like, a base character control, like, for moving it around in the scene. Like, that's usually pretty important. You can call this root or character control or like, whatever you want. And I would go parent everything to it. I don't need these anymore. These are just the automatically added buffers. Here's character root. Moves the whole character around. Yeah, except for the eyes. We'll get back to that in a second. And is fully scalable, by the way. That's also a thing. So yeah, I mean, we now have, there's a lot of little frills we might want to add. Among other things, we might want to color some of these controls, you know, differently to make them easier for people to distinguish and select. We might want to add like a little line that goes to the pole vector so that they're a little clearer. We might want to add some space switching. I mean, there's a variety of things that would be nice to add. But even if you did not do any of those things, we here have a perfectly good rig that you could perfectly well animate with. Like, there's nothing that would stop you. I mean, it wouldn't be quite as nice as a case in which you had gone in and done some of that stuff, but nothing about the rig as it currently stands would stop you from being able to animate with it effectively. It just wouldn't have, you know, maybe a few features that would be nice. And let's see, how long did that take us? Well, I think it took us about 1 hour and 20 minutes from scratch, right? You know, no auto rigging. All we did was do contour stuff.
Yeah. And it would have been significantly faster if you hadn't been there.
That's true, because of course I was explaining stuff along the way. I'm just like messing around with stuff because it bugs me when it looks like that, you know. And if we were going to do the eyes, we would probably rig those in a fairly conventional way. Yeah, let's do that just to, you know, just to say, like, yeah, this rig is officially something you really could use. Because, like, obviously you can't do that when the eyes are hanging around doing nothing.
It is a little eerie, honestly,
Yes.
when you move the head and the eyes remain put.
Yep.
There's something like the Cheshire Cat, but more unsettling.
Gonna buffer them again. The moment I learned to do any Python scripting buffers was like the first thing I did. Actually, since you've now seen me do it manually multiple times, I really, really want to script it. I think I'm going to. In fact, I think I happen to have some code hanging around to do that exact thing right here. Let me name it first. Oh, right. I also have to import PyMel if I want that to work. Parent these to the head. Make a cluster. You don't really need it to actually be a real joint in this case, and obviously this isn't contour related because it's just a completely rigid thing. You just throw a cluster on it. Alright, so now, yeah, there we go. And we'd be able to do this. We don't have like an aim or anything. We could do that. Personally, I actually don't like using aims for eyes. I'm going to, because this is, you know, our intent here is to do something pretty simple, I'm going to leave this the way it is. You could perfectly well be like, yeah, I'm going to make them look over here or whatever you want. And let's do these as the last thing. And that we are certainly going to use contour for. It's bones that I need. Actually, I'm going to use a bone CV for the middle here. And actually, that's going to be an interesting case in terms of showing, you know, the flexibility of the contour hierarchy. Where the heck are they? Oh, I'm not showing joints. All right. Now, you do not have to, in the case of bone CVs, they are not obligated to remain here like right in the middle in a straight line. Adjusting, we don't have a nice handy tool to adjust them like we do with joints. But if you select a bone CV and you hit the up arrow to get the bone CV socket, and let me show you what that looks like in the hierarchy. That's just, you know, something that is parented to a joint and it goes along, it's alongside the bone. If we select the socket, we can see what its actual rest position is, and that can actually be adjusted. Although, I think I adjusted it in the wrong direction. There we go. And we can bind in a bent position if we want to. There we go. Oh, I see. They're not even the same mesh. This is the kind of thing I really love doing because it's like, well, when you have a case here where you have one single one, you literally don't have to do anything. This just works. But it's not necessarily what you want in terms of hierarchy because bone CVs are, you know, they follow along with the joint, not the other way around. And in this case, you probably do want an FK hierarchy, which we can do. And there's a number of ways you can do that. I mean, you could have a separate, you know, set of controls. Let me just name these. Assuming those actually are ears. I don't know. They might be antenna or something. But in this case, we can literally do something like this. We can take these two bone CVs out of the hierarchy. We can buffer them. We can take these two joints out of the hierarchy and buffer them too. Then we can parent the buffers to the joints you'd expect. And even though we have completely broken the retools hierarchy, the contour hierarchy, I should say. We used to call it retools all the time before it got renamed. And we now have perfectly good buffered controls that are FK, where a joint is being driven by a bone CV. And contour has no issues with that. That's perfectly fine. I mean, it does mean that some of our tools, like for, you know, doing stuff to joint chains, won't know what to do with it, but that's not necessarily a problem. And then finally, right, so obviously there's this. This has got to get parented to something. Let's parent it to the head. It's that sort of simplicity of like, yeah, you can reparent some stuff. You can parent things where you need to be. You don't need to necessarily be thinking about a lot of complexity about organization unless you need to. I mean, you might need to, right? But the tools themselves don't necessitate it. that we really, really wanted to allow for. So here we've got some nice ear FK controls, and the only other thing we really need to do to make those work is to add some circles to them. There we go. Now, very last thing that we need to do is to get rid of all of the shape nodes for these joints and bones. And the reason why we need to do that is that for various reasons, and it varies a little bit between different versions of Maya too, Maya can be a bit slow to draw custom locator shapes. And that is, not a huge, depending on what you're doing, it may or may not be a huge performance impact. But when you have a bunch of characters in your scene, especially, it actually really can be. So generally
And it's
speaking,
worth noting.
yeah,
It's worth noting, by the way, that performance hit happens even if you hide the.
that's right. That's right. It does. It has to do with how VP2 works. So we are going to delete all contour shape nodes. And the nice thing is, well, you delete them, you get this nice speed boost. If you need to do more stuff in your rig, you restore them. You just put them back, and nothing's changed. So all of the actual contour nodes that do the actual deformation and stuff are all still there. And the actual bones and joints are all still there. But they no longer have shape nodes attached to them that are custom because, Maya doesn't necessarily like that. All this stuff still exists. And you can always put it back. So yeah, I mean, here we have like a rig. It is a completely viable thing to animate with. And it was built in a very, very short, and I keep selecting the wrong thing. Damn it.
And I do
Very,
think
very short period of time. Yeah.
Maya has gotten faster at drawing custom locators, and hopefully at some point, haven't tried it in 2023 yet, but hopefully at some point it will become on par with their own locators.
Yeah.
Which would be nice.
I'm just doing some posing, some of which is pretty weird looking. Obviously, we'd probably also want to add some like fingers and stuff. Look at that. I can just drag this stuff out if I want to stretch it in FK. I don't know. This is obviously not like much of a pose, but hopefully you sort of get the idea. Like this was all rather easy to set up. And that's like the aspect of contour, the fact that you can sort of throw some stuff down and without too much effort have a reasonable thing that we didn't feel was really getting across with some of our earlier streams where we were really getting a lot more into the weeds of like how would you use a few specific techniques. There are a few things that I would correct here, but yeah.
Yeah, and also just like some things that I think, some of the basic foundational techniques I think are a lot more easily shown with just something simple like this, especially things like overshoot using constraints to make overshoot work well, how to put together that spline-based spine, and things like using two chains for the foot. I mean, those are some of the big takeaways, I think, for this.
Yep.
Not just for the foot, but for anything where you have like a sharp 90-degree bend in the mesh at rest.
Yep,
So
absolutely.
I think this was worth, and I think that this is a good reference if somebody wants to know how to make a very basic contour rig. I think we will extract this. I mean, it'll basically wind up being most of the stream, but
Right.
I think we'll extract this, throw it up, and sort of a good tutorial.
Yeah, I think so. That's something we've wanted to do for a long time. Just have a like, look, I just sit down and I rig a character from stem to stern, and like it doesn't actually take that long. And have that as an example, in part also because people who started using Contour have said that while the manual does have all the necessary information in it, they don't all. It's not always obvious to them when there's a few things that are different, like the foot example of doing things at 90 degrees by using two chains, or the necessity of overshoot, or like in order to get the advantages of Contour. Like that stuff's all present, but it's buried under a pretty large amount of information. And watching a video like this, hopefully gives people a little bit of an easier in to how would you go about rigging a simple character with Contour. So, that said, so I do have to get off the stream pretty soon. I've got other stuff to do, but I would certainly be happy to take some questions for a few minutes. And if anybody has, further questions like about this or any other subject related, actually, or rigging in general, or anything you want, like, you can ask me what I think about the Brooklyn Dodgers, but I actually don't know who that is. So, the
I feel like that's really a callback to the distant past.
I mean, it's a callback to Who Framed Roger Rabbit, is what it is. But otherwise, I would have no idea who that is. But the in any case, yeah, totally. Feel free to ask some questions or don't, and the stream will come to a close.
How about them Mets, who are still in New York, by the way?
I see.
Yeah, not a big baseball fan, I guess. All right.
Not particularly. It's just not my like not something I had in my cultural background.
I grew up in a pretty rural area where there were not budgets for things like football for schools. So and it was kind of during the time period when soccer was just sort of rising, as or football if you're not from the U.S. So baseball was definitely it was the sport that everybody played in school. So it was a pretty big deal. Yeah.
Yep. Yeah. No.
And Jeff,
Right. Go. Sorry. Go ahead.
Jeff Trent says thanks for the demo and thank you very much for coming by.
Yeah,
And watching.
absolutely. We're like we definitely are appreciate everyone taking some time to watch our streams, and we hope it's been good for you. And so now I'm looking at it too, and so Adam W. Parker says, "Thanks, everything was clear. I'm amazed at how great the elbows and knees deform out of the box." Yes, that is like a big like I'm glad to hear you say that, and every time people say that, I'm glad about it because that is a really big thing that we wanted out of this, right? Like it goes back to if you can get something that just always can deform a tube nicely, so many problems in rigging are basically that problem. And
And one of the things about it that's nice, and I think one of the things that maybe sets it apart a little bit from offset curve deformation, for instance, which is
mhm,
something that Sony did a while back, is that offset curve deformation is sort of aware of things like elbows and knees, whereas contour really isn't. I mean,
right,
it's just the shape of the spline. So you get that same thing essentially anywhere with this curvature in the
right.
spline.
And regardless of what's making the curvature, there's nothing really like in terms of how the contour deformation and deform field behaves. There's nothing special about joints or bone CVs. Like they do different things in terms of like how the spline is generated. But the deformer and deform field just know that there's a spline, and they just do what they do with the spline, and that gives you a lot of flexibility. Like you could have, like I don't know, like let me just throw some bone CVs in here. Now there's some additional bone CVs. Like if I create, so the purpose of a joint as opposed to a bone CV in part in contour is that the joint creates like more of an acute bend, like you'd have at an elbow. But if I happen to have two bone CVs and I stuck them close together so they made an acute bend, you're getting the same kind of thing, right? The same kind of like nice deformation. If we look at this, well, all right. So there's not actually that much geometry here, so it actually is a little hard to see. But you'd get something similar even if there was, right? In the sense that you'd get the mesh being sort of spread around on the inside of the curve to give it sort of some nice fair curvature. Um,
It's the spline that drives things, and
right,
in theory, you could even take your own transforms. I mean, if you really understood how the contour scene graph works, you could even take your own transforms or whatever and plug them into the right attributes. And in fact, you would get a spline and you would still get the deformation. I don't know that. I think that would be a pretty advanced technique, and it
yeah.
might be useful in some cases. I don't think it would be a real common use case, but you could do it.
Right. We mentioned in the manual that that's possible, but we don't tell you how to do it because we don't think that anyone's going to want to do that. But potentially, larger studios that write their own rigging tools, and if you write your own internal rigging tools and you would like to drive the contour, spline with your own transforms, like you can certainly talk to us about that, and we can help you do that. But it was sort of beyond the scope of what it was reasonable to sort of give people good tutorials or good information on doing in the manual or in a stream.
All right. Well, I'm thinking then, if nobody else has any other questions, I think because of the delay, we'll wait another minute or two. But
Yep.
I'm thinking otherwise, probably a good time to wrap up.
Yeah, I think so. Thank you guys for coming to our stream. Um, I'm contractually obligated to say that you should like and subscribe. I think that the stream police come and take you away if you don't say that. So do that, or I'll be taken away by the stream police. I'm sure you don't want that. Um, and thank you all for coming. And yeah, we'll wait for like another minute. But if there's no other questions, then I think the stream will be done.
Okay, great. Well, thank you very much, Raf.
Yep.
Thank you very much for everybody who came by and watched. And hopefully we'll. Okay.
We have another question.
Okay.
What about longer type object rigs? I'm not quite sure what you mean by that, actually. This is from Corollas Galkus.
So are we talking about like hoses here, for instance?
Ah, that would make sense, but I don't know if it's quite. Yeah, snakes, ropes,
Yes.
yeah, stuff like that. Yeah, it works quite effectively for that purpose. And what you and I don't. I mean, like, I'm tempted to just be like, oh, I'll throw in a cylinder, make it super long, and rig it, but I don't really have time right now. But yeah, it does. So there's a number of ways you can handle that, and one of them would be to just make the whole thing one bone, actually, and just have a bunch of bone CVs. And that basically gives you like a pretty nice like tail rope type rig. Like actually, that by itself works pretty well. Is you literally just like draw in one bone, you put like however many bone CVs you want on it, like the end. Now, the one scenario that can come up with that technique where it can be an issue is that if you've got a lot of bone CVs and you twirl your thing around and it's doing like a whole bunch of stuff, you can get into a situation where you get some strange twist behavior. And that's solvable, actually, because bone CVs don't normally use their transformation to contribute to twist. So it would be looking at the twist only at the beginning and the end of the chain, which, if your chain like loops around and does stuff, that might cause the twist, like that might cause, the twist to pop in various places because the 180 degrees, twist from one side to the other may mean something very different depending on the exact curvature. To solve that, what you would do is use transform twist on a bone CV. And that means that let's turn on. You can,
Right. To be clear, it's an attribute.
right, it's an attribute. And that means that your bone CV, just like joints do, its transformation, right, also controls twist. And so that's how I'd go about. I'd probably use that if I was doing like a snake or a rope or something. But
Also worth noting that bone CVs have their own twist attribute, which
that's
layers
right.
additional twist on top of that. So you can also do some extra rigging as well to
That's
get
right.
more control over the twist along.
Yep. If you wanna have like more direct control over it, that does require you to be doing a bunch more work to figure out what the twist should be. So generally speaking, just using transform twist is an appropriate answer to that question. But there are definitely scenarios, especially in more complex, more sort of for lack of a better term, like studio rigs, where people may definitely want to directly drive the twist attribute, and they totally can. It's just a more advanced technique.
Yeah, and Raf, you made like an example scene a while back with basically a cylinder tied into a knot
That's
that
right.
was animating a little bit, and I always thought that looked really good. And you do get, I mean, that's a pretty extreme example where you've got this cylinder just sort of looping around and looping back through itself, and it looks great. It looks almost like an illustration from a Boy Scout manual or something.
Sure. Yep. Yeah. No. I mean, there's a lot of stuff that you can do with this, and we've actually done a number of things. And there's even one of the examples on our site of a project that was done with Contour where it was like this snake, but the snake was actually this thing that was meant to be like it was meant to mimic sort of a cut paper look, and the snake actually had no deformation at all. It was purely using contour deform field constraints to drive a bunch of like little like cut pieces, as if they were deforming. So you got both the advantage of being able to just have a bunch of bone CVs and just sort of like, animate your snake to do whatever you wanted, as well as the ability to sort of move a bunch of scales around without having to do anything particularly complicated. It was just a bunch of contour deform field constraints.
Yeah, I'm going to put a link to the YouTube video of that in the
Yeah,
description.
I think that's a good plan.
In the chat.
Yeah.
This is a good example of why the constraint is so useful, right? Because
Yeah.
in fact, nothing here nothing here is directly bound to the spline, but everything is constrained to the spline. So everything's rigid, but it just sort of moves along very nicely with it all.
Yep. I mean,
I
this
think
was the
it's
sort of thing, and to be clear, like this particular project, like this entire that entire production was done. I mean, I don't advocate this as a general thing, right? But that entire production was done stem to stern in 2 weeks. It was an advertising thing, and the advertising world can be like that,
right.
And like if you can imagine having to do that conventionally, it was basically all the rigs had to be done in one day. Like there was really no reasonable way that it was going to happen if they weren't done that quickly. And I'm like, if you actually had to solve these rigging problems in a normal fashion, I don't think that would have been viable, right? I don't think it even could have been done. Whereas here, all those problems were pretty easy, and it wasn't really a big deal, and it was still a challenging project because the schedule was so short. Like I said, I don't actually advocate doing stuff like that, but the advertising world is sometimes like that, and you know, essentially it enables, like, this was a way, and I say this in the introduction to the manual too. Like rig tools destroyed my fear of rigging, right? Where you have that thing where you encounter a project and you're like, oh geez, like, yeah, I mean, maybe we can do this, but like, do we have time to like actually get this to work? And I no longer feel that way about rigs most of the time. Like, obviously there are some cases where it's just like, oh well, this is just never happening. But
Well, and there's some stuff that rig tools isn't
sure,
applicable
sure.
to too. If you're getting that feeling about some facial rigging, rig tools may not fix
Right.
that for you.
It may or may not. Like, there's definitely cases where rig tools is useful in facial rigging, but it's generally, really useful in body rigging, and sometimes useful in facial rigging. But generally speaking, it is still sort of true that, like, I look at rigging challenges and I'm like, oh, this is really not that big a deal anymore. In a way that is very, very different than I would look at them if I had to use conventional techniques. We've got projects that I mean, like, here, let me throw another example out there. Actually, this was also a very, very, very short project, and it's got a few rough edges as a result. A more recent one. Oh hey, they put up the new one. I didn't even know that was up yet. This is fresh
It's time
off
to
the.
upgrade your work and
Is this
product.
HTH?
Yeah, it is. H4H.
H4H. I'm sorry.
This is some work I've been doing for a company called Hero for Hire. Um, and let me actually, the new one is up there. This one, it like just came out. I just posted it in the chat, and yeah, I mean, similarly, like, this is a case where this character was rigged in like 4 hours, I think. This is also ephemeral, by the way. Like, this is the ephemeral system being used to animate the character as well. And again, if it wasn't any of those things, like, I'm like, yeah, I don't know how this would have happened. But it is also, when I'm talking about how the schedule was really truncated, the part that I was directly involved with was just the character. Like, H4H handled the background and the effects and a bunch of other stuff, and they also had a tight schedule. But that wasn't something that we had to, me and OpenPixel, who were the ones doing the character and character animation, had to handle in our schedule. But we did have to get the whole thing rigged. We did have to animate all of these shots and lay them out. And that also happened in about a 2-week span of time. Again, not a viable thing if you weren't using contour, and I don't think a viable thing if you weren't doing it ephemerally either, actually, given the number of shots that we have going on here and the stuff that's going on in those shots. Also, not a viable thing if we didn't render the whole thing in UE, so there's that too. But maybe we'll do something on that for another stream, actually, because there's definitely stuff about the about Little Bird, about the UE rendering system that I would love to show people. Not really notional pipe specific, so it's not really something we're necessarily going to get to soon, I think. But
Sure.
maybe something we'd like to touch on here too. But
Yeah,
anyway,
because in general, I mean, what we're really interested in is basically how do you do high quality production quickly, right?
yeah, exactly.
How do you remove the unnecessary complexity from it, right? Because there's always going to be some necessary
Yep.
complexity. The work has to get done, and it has to get animated, and that's some work. But how do you get the other stuff out of it to let
How do
people
you remove all the friction from the process, right?
the friction? Yeah,
Yeah, I mean, I hadn't been using that term a lot recently, but it came up, and I actually started to feel that that's a really, really good term. Like, friction is what we experience in CG basically all the time, and it's what often holds us back from making better work, right? So let's remove that wherever we can. Which is it's hard work to do so. It's really difficult, which is why it hasn't been done in a lot of cases. But its amount, the ways in which that can change your what's possible is extremely significant. But anyway, I need to get going now. So again, thank you for coming to our stream, and thank you for asking us interesting questions. And we'll be here again next week at the same pipe channel. I don't know if that works. That really doesn't work. I'm going to retire that one. But
yeah, yeah. I feel like that one once was
no,
probably
it really once was enough. That one didn't work at all.
yeah. Okay,
Anyway, yep. And I
all
am
right.
signing off.
Thank you
All
all,
right.
and see
Yep.
you next time.
Bye.
Bye bye.